Good morning, everyone. Today, I will try to present to you CPE120 Assessment Number 2, as presented by James Dylan A. Santos. Now, what is the project all about? It's about a smart segregation system that will identify your garbage and then sort it into the proper bin so that it can be recycled, biodegradable, and non-biodegradable. It can be sorted into those three options. Now, the design requirements for this design is it needs to, well, first detect the trash, it needs to sort the trash, needs to show feedback that it did this. It should work with low power so that it can work and is safe for the user to operate and make it affordable to use and make. Now, this is the morphological chart provided by the assessment, and these are the concepts that I generated. The generated concepts are then graded with the Pugh's matrix as with concept 1 as the baseline. Essentially, we graded it as plus when it's better than the baseline, 0 when it's the same with the baseline, and negative when it's worse than the baseline. So we graded it in terms of functionality, cost, ease of implementation, maintainability, safety, innovation, and we totaled the numbers, and whichever one has the highest points, we crown as the winner. Now, I'm not going to go too in depth with this matrix and why it's assigned that. It just know that uh IR sensor is arguably the worst of all when it comes to detection. Camera is the second best. Inductive sensor is way too situational since it's good for metal but not as well in comparison to other types of trash. And ultrasonic sensor is it's good, but it's way too complex in comparison. And we might not have the luxury of using it in mass production. So it was graded uh, with the Pugh's matrix, and whichever one got the highest number of points was crowned as the winner. In this case, we tied with concept number 3 and concept number 5. The concept number 5 is inductive sensor, which it's good for metal, but not much else. Like I said, it rotates a platform to drop the trash right in the right bin and works with solar so it can be used outdoors. Cost is moderate but needs more setup. So yeah, as stated, it needs setup. And comparison, concept number 5 is a mix of simple and smart. The camera detects the type, the Arduino controls the servo to move the gate, and the battery gives signal. Cheap, smart, and effective. Blah blah blah. Now, we first run the concepts through the matrix, Pugh's matrix, and then once we got the tie, we compared it to our baseline, and we we graded it on a scale of 10. Afterwards, uh we ba- uh we graded it by the criteria of functionality, cost, ease, maintainability, safety, and innovation. We graded each of these criteria differently out of 100%, and whichever point we assign, like for example 7, we multiply it by the weight, which is 0.25 when we convert the 25% into a number that can be multiplied. Anyways, when we graded everything, the concept number 1, concept number 3, and concept number 5, based on the criteria, the concept number 5 won as the best overall, with concept number 3 and concept number 1 almost tying. And now the selected concept number 5, I will try to explain the rationale of why it was chosen. Essentially, like I said earlier, the camera is the best type of selection sensor for the trash, since with the rapid rise of AI, we can uh, use its image detection softwares to try and identify what kind of trash was put in the chute. Compared to the others, which may not work as well, the camera is the most cost effective and the most efficient and effective to use in terms of cost and stuff. We use the servo power gate compared to the others since it's simple and not many moving parts can go wrong compared to like a rotating uh what do you call this? A rotating platform or a air pressure what do you call this? A pneumatic pusher. So the servo gate works better compared to a conveyor belt, which has a lot of moving parts, so you're going to have to maintain that. A rotating platform is probably the second best, and then pneumatic pusher is the most expensive. In terms of feedback system, the LED and buzzer is good. They can be tied. The LCD and can be very expensive compared to the other options, and mobile app notification is, well, who wants to download another app? We have a lot of that already. For the controller, we chose Arduino Uno since it's essentially the simplest, and we only need simplicity for our design. We don't need to go overboard. And for the power source, we chose a wall adapter since, like I said earlier, we don't want to keep changing battery packs. Solar cell is unreliable, especially at night, and USB power is not feasible in this design. Now, we're going to show you the simple sketch. This is it, the representation. Do note that this is just a simple sketch. The final design could be different, but it works on the same principle as this. It's just that we're going to remap it a bit. Now, this design works by uh, when the trash enters the chute, it's going to be identified by the camera. And once it's identified, it's going to open the entry gate servo and either open the first gates for, like for example, biodegradable. If it identifies it as biodegradable, it's going to open the entry chute and it's going to land where the first servo gate opened. If it identified as non-biodegradable, it's going to be sorted into the second servo gate, which will open this second gate and this second gate, while the first gate will remain closed and the entry gate will open. So essentially, yeah, that. And if it detects that it is recyclable, it's going to open the entry chute, open the second servo gate, only the top part, not the one near the wall. And it's going to open the third servo gate so that it's going to land on the recyclable chute. Essentially, it just works on the same principle as this factory sorters. The same principle, not the same design, since these uses a conveyor belt. It's more akin to the factories where they detect the defective, like for example, those that work with a pencil factory where they run through a camera and it detects a uh if it's not up to par and it's going to essentially push it out of the running conveyor. But instead, we use the principle to sort the garbage. The standards considered were firstly IEC 61010, which is for electrical equipment since we don't want to sap anyone. ISO 13849-1, safety for machine control parts since it has moving parts which can crush fingers if used improperly or designed improperly. And lastly, we used IEC 62368-1, which is for overheating and the prevention of such, since we don't want it to overheat and burn users or overheat and malfunction. Now, in conclusion, we chose Concept 5 because it is the most practical for us to use with simple parts that little will go wrong and is not needing to be regularly maintained. This can help keep our school green and eco-friendly so that trash will not flow about and be sorted into the wrong bins. Thank you all for watching, and this is my rationale for the choices that I made with the design of CPE assessment number 2. Goodbye.